Okay, so in this video we'll look at how to find the slope of a line from a graph. So here we have a graph of a linear equation. You can see that that graph is a line, so it's a graph of a linear equation. So when we think about slope, there are a couple different ways that we can say what slope is, but we want to think of it as the change in the y values between 2 points that are on our line divided by the change in the x values of those points. Oops. I should probably spell that correctly. There we go. So if that change is vertical, it's positive. If it goes down, it's negative, and with the change in the x values, if it goes to the left, it's negative, and the right, it's positive. Although you generally measure slope always from left to right, so this is almost always positive. So let's do that. So we can choose any 2 points that fall on our line. I've already chosen 2 points here, but understand you can measure slope any 2 points on your line. So I want to go, in this case, always start with your left point, move to your right point. So start on the left, move to the right. And I'm going to draw sort of a triangle here. And just go up until I'm across from this other point. So that's the change in my y values, or my vertical change. And that would be, just count the 1, 2, 3, 4, 5, 6. So this, we use a delta, a Greek letter delta for change. So the change in y, or delta y, is 6. And it's positive because we moved up. If we moved down, it would be negative. I'll show that in a minute. So our change in y is 6. And then however far we have to go to the right to reach our point, we go over 3. So we could say our change in x, or we write that delta x, is 3. It's kind of squished there. Sorry about that. So our change in x is 3. So I'll leave a space here. I'm going to write something there, but anyway, I'll come back to it. So remember, our slope is whatever our change in y is over our change in x. So our change in y was 6. Our change in x was 3. So we would say the slope is 6 over 3, or we should reduce it to 2 over 1, meaning this line goes up 2 spaces for each 1 space it goes over. Right? It goes up 2 over 1. We can see that. Up 2 over 1, up 2 over 1. Or up 6 over 3, right? Up 6 over 3. And that's true for the whole course of the line, right? Up 2 over 1, up 2 over 1. We also will probably just, you'll see this expressed just as the whole number 2, but remember to think of slope as a fraction always, so that you have your change in y, your vertical change, over your change in x, your horizontal change. Put something else here. Some people, when they talk about slope, they say rise over run, which again is just a way to remember rise being up and down, run being horizontal. So it's just a way to remember change in y over change in x. So that's the slope of the line. Slope describes the direction the line moves, how it moves, right? So this line moves up 2 spaces on the graph for every 1 space it moves to the right. So let's look at another example here. So here we have a line. Notice this line, if we look at it from left to right, is moving down from left to right. And if I put my pencil on the left side and I go across the line, it moves down as I go from left to right. Now, the previous one we did, if I did that same thing, if I put my pencil on it and move from left to right, my pencil's moving up from left to right. And notice we had a positive slope. So what we'll see here is that lines that go down from left to right will always have negative slope. So let's do the same thing. So remember our slope. It's good to write the definition here. We can also say change in y values, right? Change in x values. So remember, this is the vertical change. If we go up, it's positive, down, negative. And this is the horizontal change. And if we go to the right, it's positive. And if we go to the left, it's negative. So again, start with your leftmost point. You can use any points. Obviously, pick points that are on the lattice here, right? Intersecting perfectly with the lattice. So I'll start with my left point. Now notice to get to this point, this time I'm going down. So I go down. So my change in y will be expressed as a negative number. So I went 1, 2, 3, 4 units down. So I don't want to put 4, I want to put negative 4. So we go down, it's negative. So my change in y was negative 4. And then to go over, my change in x, 1, 2, 3, 4, 5, 6. So my change in x was 6. And then just express that as a fraction or as a ratio. So my change in y always the numerator, so negative 4. My change in x is 6. So notice, like I said before, if you're going down from left to right, you should get a negative result for your slope, and we did. We should always reduce, so we'll reduce this to negative 2/3. So that means this line moves down 2 units from left to right, down 2 as it moves 3 to the right. And we can see that's true. Down 2, right 3, we can see we're on the line. Down 2, right 3, we land on the line. Down 2, right 3, we land on the line. So this shows that the line keeps moving in a constant way. So that's finding slope. A couple special cases I wanted to show were vertical and horizontal lines. So I'll show those two really quickly. So here we have an example of a horizontal line. So all horizontal lines have the same slope. So we'll look at that. We can try to find it the same way, right? So if I choose any 2 points on my line, I can calculate the slope. This is a horizontal line, meaning a line that moves straight left to right, doesn't go up or down. So again, slope is defined the same way. That's not going to change, right? We have change in y over change in x. But what we notice here is when we go between these 2 points, we didn't move up or down at all. So my change in y is 0. And my change in x, I moved over 4, so my change in x was 4. Well, 0 divided by any number is always 0. So we can generalize to say that the slope of a horizontal line is always 0. So anytime you have a horizontal line, if you're asked what the slope is 0, because there's no change in y, right? It doesn't move up and down. So no matter what the change in x is, it'll always be 0 here. So let's look at a vertical line now. These are kind of two special cases. So finding the slope of a vertical line, right, we'll do the same slope definition. So change in y over change in x. You'll also see this written as delta y, delta x, that triangle, or the delta character from the Greek alphabet. So sometimes you'll see it written that way. I'm just writing it out since we're talking about it for the first time. So again, choose any 2 points on your line. Now this time, because I chose those 2 points, my change in y, right, it goes up 3. And my change in x, my horizontal change, is 0, right? I didn't go over at all to reach this second point, so I have 3 over 0. Now don't be confused, 3 divided by 0 is not 0. 3 divided by 0 is a special case we call undefined. You can't divide a number by 0. So we would generalize to say that the slope of a vertical line, oops, it's not very good. There we go. Slope of a vertical line is undefined. That's how we say it. So if we hear that the slope is undefined, we mean that that graph is vertical between those points. So it's moving straight up and down. So we call this undefined when we see this. And that's calculating slope from a graph.